Hey, hello to everyone. This is Akansha. In this video, we are going to discuss the rearrangement reaction known as a Beckmann rearrangement reaction. So let us see the statement of this reaction. The rearrangement of the oxime functional group to the substituted amine, that is a rearrangement reaction involving the conversion of the oxime functional group to the substituted amide, is a Beckmann rearrangement reaction. This reaction basically is get catalyzed by the acid, and these rearrangement reaction leads to the conversion of the oxime functional group to the amine. So let us see the reaction scheme of this name reaction. You can see here the oxime under the presence of the acid is get converted to the amide functional group. This is what we have to do in the Beckmann rearrangement. Let us see the mechanism for the above reaction scheme, that is a Beckmann rearrangement reaction. The first step is that there is a formation of the oxime molecule. The oxime is get formed by using the ketone and the hydroxyl amine. What will be the first step over here? That this H2O will be loose over here, and we will get the oxime as our starting material, which is required for a Beckmann rearrangement reaction, NOH. Now, as we know that the Beckmann rearrangement reaction are catalyzed by the acid, so the next step is the acid, use of the acid. Now, due to the alpha effect, what will happen over here? This oxygen will get protonate by using this H plus. Then what will be the next step? PH, CH, double bond N, O, H, H, and as the oxygen donates its lone pair to the H plus, there will be the positive charge. After that, as oxygen is an more electronegative, it can't bear the positive charge on itself, so it will take this bonding electron pair and remove as a stable water molecule. This will be the loss of the stable water molecule. So what will be the formation over here? That this PH, C, double bond N plus, and here there will be the H. Now there is a formation of the electron deficient nitrogen. So nitrogen is the electron deficient over here. If we try to compare the migratory aptitude between the pH and H, we will find that the migratory aptitude of hydrogen is more than pH. Then what will happen over here? That this hydrogen will migrate towards this nitrogen. This hydrogen will migrate towards this nitrogen, and then there will be the formation of double bond NH. Now this nitrogen will get neutralized, and here there will be the formation of the positive charge on the carbon molecule. Then in this the water which was loose in a previous step act as a nucleophile over this the electron deficient carbon center. Then what will be the next step over here? That PH, C, double bond NH, this will be as it is, and on this electron deficient carbon center the water will act as a nucleophile. As the oxygen donates its lone pair of the electron, it will carry the positive charge. Then the next step is that to neutralize this positive charge, this H plus will be free over here, and then it will be like this, double bond NH and then OH. The last step is a tautomerization step. What will happen over here? This will shift over here and this will shift over here, and then we will get the amide as our required product of Beckmann rearrangement reaction, double bond O NH2. This is the amide. So you can see over here from starting what is the first step. It is the first step is a formation of the oxime, which is formed by using the ketone and hydroxyl amine. The oxime is get formed. The oxime is get protonated due to the alpha effect. Then after there is a loss of the water molecule over there. Then as the migratory aptitude of the hydrogen is greater than the pH, that is a phenyl group, it is migrate over there. Then here the electron deficient carbon is get formed, over which a water molecule acts as a nucleophile, and then there is a formation of the amide, which is our required product. This is how the rearrangement of the oxime functional group to the amide take place in the Beckmann rearrangement reaction. Now, after this, seeing the mechanism, we will focus on some sort of the examples of the Beckmann rearrangement reaction. Now, focusing on the example of the Beckmann rearrangement reaction. This is one of the famous example of the Beckmann rearrangement reaction. In the starting material is given as a cyclohexanone. So, let us solve this question. That is, starting material is given is as an cyclohexanone. Then on the arrow, hydroxyl amine is given. So, what will be the first step? This H2 and this water will be eliminated over here, and we will get the oxime. The first step is that we will get oxime over here. After the formation of the oxime, what will be the next step? That acid is get given by that acid will protonate this lone pair on the oxygen atom due to the alpha effect. Then NOH2, and here there will be the positive sign. After that, this water molecule will be leave over here, and then there is a formation of electron deficient nitrogen in the next step. Double bond N plus, then as here, then migration. After the loss of the water molecule, there will be the formation of the electron deficient nitrogen. Then the migration of the group take place. Either the groups are same which are attached over here, so any of the group can migrate. So what will I do? I will migrate this group towards this nitrogen, as the deficiency will over, and the deficiency will create over this position from which a group has been get migrated. After that, the water molecule which is present will act as a nucleophile over here. Then after the attack of the nucleophile, the same procedure whatever we have done in our mechanism is get followed over here, and then later on we will get a product as the amide. That is, this will be our product. This product is known as a caprolactam. This product is known as a caprolactam, and these products act as a feedstock for a nylon 6. So this Beckmann rearrangement reaction, we said it as, this is a most famous example of the conversion of the cyclohexanone to the caprolactam, which is used as a feedstock for the nylon 6 polymer. So in this way you can solve the examples regarding the Beckmann rearrangement reaction. Hope you enjoy this name reaction. Any difficulty, post it out in the comment. Thanks for watching this video.